Okay, so what we're going to look at here are three reactions of permanganate and peroxide. So, because peroxide can be oxidized or reduced, or can be a reductant or oxidant respectively, it's quite a good thing to use. What I've set up is peroxide with an acid here. We've done it with sulfuric acid, doesn't matter which one, we just need the H+ ions to make it acidic conditions. I've added nothing to the peroxide here, so it should be neutral, because peroxide is neutral. And here I've added sodium hydroxide to make it alkaline. The one that you should be used to is, and I'll just put a drop of permanganate on here so we can see that it is quite a dark purple colour. Okay, spread that out. On the video it looks very black, I see. Okay, so it's quite a cool purple colour. We're going to see what happens to that purple colour when we put it with these solutions. And then I'm going to go through how we write the balanced equations for each of these, because they are going to be a little bit different. So the one you should know, or should remember, is when we add it to acidified solutions, and if redox occurs, then the solution will actually, the permanganate solution will actually decolorize. And we can see there that that's not just diluting, that's actually decolorizing there. Okay, so it goes from being purple to being an extremely pale pink, and then if I've got enough peroxide in there, which maybe I don't, then it will decolorize. So that's our first redox reaction, the one that we probably remember from last year, where the permanganate decolorizes. If I do it without the acid, then I get quite a different response. You can see that there's a brown solid being formed. You can see the bubbles this time is actually reacting a bit quicker. And that brown solid is manganese dioxide. So in this one, we've made manganese. I'm sorry if the writing's not particularly clear, but I'm doing it upside down. Manganese 2+ was our product there. In this one, our product was a little bit different. It's manganese dioxide. All right. So in this last one, which is going to be acidic conditions, here's where I'm really hoping that I've put enough, sorry, not acidic, alkaline. Here's where I'm hoping I've put enough sodium hydroxide in to give you another thing, and maybe I haven't because it's made that brown. So I might need to add just a little bit more base there to get the right result. No, I might have to do that one again. Okay. So I'm just going to go set that one up again. This one here is a little bit harder to get going because it does need very alkaline. So clearly I didn't put enough sodium hydroxide in this. I'll start with the sodium hydroxide this time and do it quite a lot. And actually, I'll make my peroxide, my permanganate solution alkaline. So we need a couple of drops. And I'll add the, here we go. And that's what we expect. There's still some peroxide left in there, but I'll add a bit more so it happens. And we should see a bit of a green film around the edge. This is the one that I always find very hard to do, but if I add a bit more permanganate to it, we should get a little bit of green colour at the edge. It hasn't worked particularly well. It very quickly neutralises this reaction, so that's why it's hard to get right. Third time lucky. The joy of chemistry doesn't always work well, especially when you're videoing. So, as I say, third time lucky. Let's see if we can get it to work. So there's still a little bit of peroxide in there. I'll just add a drop more. And if I add this to the side, we hopefully get the colour, the green colour forming. There we are. Okay. So rather than getting the brown that we've got there, you can see a bit of a green forming as well. It's quite a bright green. It's just not much of it. There's just some in there. Oh, I've just knocked it. That was very clever. But we get the different products. And this one here is MnO4, so it's still MnO4, but now it's 2-, so it's got a different charge. So the oxidation number here is going to be +2. The oxidation number here is +4. I hate doing 4s upside down, so I hope it's the right way around. And here, it's gone from being +7 to being +6. Yeah. I'm struggling from which way around to do that. That way there would be my guess. +6. Yay! Okay, so it was hard to see in the video on this. It was actually hard to see in life as well. It's a very hard reaction to get, this one here, the alkaline one. Balancing them, this one here is the way you've done it always before. I'm going to flip around the other side so I can write it a bit more easily. Where we went MnO4 negative, going to Mn2 plus. We balance the oxygens with water, so +4 waters. We've now introduced hydrogens to that situation, so you add +8H plus, and then this side's +7, this side's +2, so I balance that charge with my 5 electrons. That's the one you've done before. This one here is actually really easy because MnO4 minus is going to MnO4 2 minus. Well, all the atoms are balanced. The only thing that isn't is the charge, so we just go add an electron to that one. This one here is a little bit trickier. And this one here, we actually balance it the same way initially, but then we have to allow for the fact that it's not going to have any hydrogens in it. Alright, so we make MnO2. You can see here that there's a difference of 2 oxygens, so I add 2H2O to this side, which would be 4H plus. This side is 3 plus, this side is neutral, so 3 electrons. However, this is neutral. There's not enough hydrogen for the ions for that to occur. So what I need to do there is, it's a bit like Hess's law in a way. We're going to try and get rid of those H pluses by putting them on this side. Well, if we're going to have 4 H pluses and we're looking at neutral conditions, we must also have 4 hydroxides. So what I'm actually putting in there are 4 times the water dissociation equation. Then I can see that that cancels out all of the hydrogens. It cancels out those 2 waters and turns that into 2. So I have a new equation, which I'll write up the top here. MnO4 minus plus 2 waters plus 3 electrons goes to MnO2 plus 4 hydroxides. Just double check my charges. -4 on the left, -4 on the right. So I can be pretty confident that's right, because I know the atoms balance out. So you balance them as if it's acidic first, then you use the water dissociation equation, much like you would in Hess's law, to eliminate the H pluses out of the equation completely, and then you eliminate any waters that are on both sides, and you've got your final equation. So that's how we go from it being acidic to neutral to alkaline. And actually it's quite good. As I've left this sitting here, a little bit of green has actually formed just at the top here, which is the colour we would expect to see. But as I've said before, and the reason it took 3 times, this reaction is quite hard to get working well.